Now it's time to learn about conceptual integrity. Conceptual integrity is about creating consistent software. It's making decisions about how your system will be designed and implemented, so that even if multiple people worked on the software, it would seem as if there was only one mind guiding all the work. Now, it's important to understand that conceptual integrity does not mean that the developers in your team don't get to voice their opinions about the software. It's more about everyone agreeing to use certain design principles and conventions. There are multiple ways to achieve conceptual integrity. One important way is communication. Adopting certain agile development practices like daily stand-up meetings and sprint retrospectives, where team members can agree to use certain libraries or methods when addressing certain issues, can help to maintain the consistency of the code. For example, team members can all follow a particular naming convention. In addition to communication, another way to ensure conceptual integrity is code reviews. Code reviews are systematic examinations of written code. It's similar to peer review in writing. It's often used to find mistakes in the software, but also to keep different developers consistent with each other. Developers evaluate each other's code line by line to uncover issues. Additionally, using certain design principles and programming constructs can also help in maintaining conceptual integrity. Consider Java interfaces. An interface defines a type, with behaviors that implementing classes of that type should all have in common. This creates consistency in your software, thereby also increasing the conceptual integrity of your software. In the specialization, you will also learn about design patterns. They provide conventional structures for your classes to solve a design issue and lead to consistency. Another approach to achieving conceptual integrity is having a well-defined design or architecture underlying your software. While software design is typically associated with guiding the internal design of software running as a single process, software architecture describes how software, running as multiple processes, work together and how they relate to each other. Much like using certain design principles, having a strong software design or architecture to guide how your software is organized creates consistency. Unifying concepts is also another approach to maintaining conceptual integrity. It is taking seemingly different things and finding a common ground so that each concept can be seen and treated in similar ways. For example, in the Unix operating systems, every resource can be seen and manipulated as if it were a file. The same set of operations can be used on different types of resources. This simplifies things by making it so that any resource can be treated in the same way. Unifying concepts to avoid special cases can provide consistency in your software. Finally, having a small core group that accepts commits to the codebase is another approach in achieving conceptual integrity. This is similar to exercising code reviews, but it restricts the review to only core members of your software team. These members will be responsible for ensuring that any software changes follow the overall architecture and design of the software. Restricting this decision to only either a single person or small group will solve any design issues and lead to consistency. Conceptual integrity is often quoted as being the most important consideration in system design. Fred Brooks, a well-known computer architect, states in his book, The Mythical Man Month, "It is better to have a system omit certain anomalous features and improvements, but to reflect one set of design ideas, than to have one that contains many good but independent and uncoordinated ideas." Simply put, conceptual integrity is about designing and implementing the software in a consistent manner, as if it were written by one person. Practicing conceptual integrity in your software can help guide your team when they are writing software. If each team member sees that the design and logic of the software is consistent and easy to follow, it will help them know how and where to change the software to meet new requirements. Let's use a metaphor to show you the benefits of conceptual integrity. Let's say that I was hosting a party, and I assigned multiple people to send invites through Facebook, Snapchat, and Twitter. If I asked you to check who will be attending the party, you would have to check different social media sites, which would cost more time and effort. If I was to use just one method, like Facebook, this task would be much easier. This is similar to writing software. Keeping things consistent and logical would make it much easier to maintain and work with. Think of your software as a building. Conceptual integrity is the consistency of the structure and design behind your building. To create a huge skyscraper, many workers would need to work together in a well-organized way. They would need a definite blueprint and an architect to guide the design of the building. Without this blueprint, workers may have no way of knowing how to build different sections of the building. Different materials and structures may be used by these confused workers. Allowing construction of the building to be informal and unguided would result in an unorganized and inconsistent structure, leading to possibly poor structural integrity. You now have a greater understanding of the importance of conceptual integrity. Conceptual integrity is a very important principle, and one that will help you to create consistent and well-designed software.